wine barrels suspended by two different cables. We're going to label force tension 1 is going up in this direction. And actually that's force tension 2. And force tension 1 will be going in this direction here. Okay, our job is to analyze the static structure then. Static means there's nothing moving, but there are still forces on it. So we'll take a look at this first one here. It's a hypotenuse going in this direction. So we can break that one up into x's and y's. Okay, that would be a y direction there. Okay, and then of course there would be an x direction going here. So we're going to call this one force tension 2 in the y direction. And the one going in this direction would be force tension 2 in the x direction. Now force tension 1 is pointing in this direction here in the x direction like that. Now if we do a parallelogram here, we can see that force tension 2 in the x is this one here, and force tension 2 in the y is this one here. And 38 degrees, of course, is still located this direction here, and there's the 38 degrees there. So we know it's a static structure. So we're going to say the sum of all forces in the y direction equals 0. That would equal force tension 2 in the y, and let's see what's opposing it. Straight downwards would be force of gravity. So we'll go minus force of gravity on that. So let's fill in some information about this. So we'll go 0 equals force tension 2 sine of 38, and then minus 420. Now where are we getting this from? Well, here's our angle. If I want force tension 2 pulling up on this in the y direction, that's the opposite side of this angle here. So imagine the vector pointing up in this direction. That's just the y component of the force going on this hypotenuse here. That has to equal then the force of gravity going downwards. So when we divide this by the sine of 38 into there, we'll get a different number. So how does that work? So we're going to have force tension 2 sine of 38 is equal to 420. And then we'll divide both sides by the sine of 38. And force tension 2 has a value of 680 newtons. So that's the hypotenuse value going in that direction. Now we need then to figure out force tension 1's value. Well, I'm going to draw in this direction here a larger vector so we can see it. This is actually the force tension 2 in the x direction. This vector here is pushing against this way. And force tension 1, now we can look at that and say, well, nothing's moving, so those two are probably equal to each other. Okay, so we're going to then say the sum of all forces in the x direction does equal 0 equals force tension 1 minus force tension 2x, or force tension 1 is equal to force tension 2x. Well, again, if we look at this, in either way we look at it, we can look at this angle here. We see that's definitely the adjacent side. And of course, this is just a parallelogram showing this as well. That's the adjacent side. The adjacent side, of course, is cosine. So force tension 1 is just going to be equal to force tension 2 cosine of theta. So I'll take 680, and I'll multiply that by the cosine of 38. And I'll get a value of 540 newtons for force tension 1. So that's 540 newtons. Okay, and I'll write that again here. So force tension 1 equals 540 newtons. So that's how you analyze a static structure. We have a vector pointing in this direction that has a y and an x component. The y component opposes gravity, and those two are equal to each other. The x component of this tension force opposes the force tension 1, and those are equal to each other. So we get a force tension 1 of 540 newtons and force tension 2 of 680 newtons.